Okay, so not completely related, but some touch points with Neil's presentation here is about for you that having and manages Elasticsearch clusters and so on. It can be, yeah, from an operation point of view, something that you want to streamline and so on. And one obvious option is, of course, to go to our managed service, the Elastic Cloud. But for those that wants to have it self-managed, there are a few different options there. But one option is, of course, to run Elasticsearch on Kubernetes. So my name is Erik Westberg, and I'm a solution architect at Elastic. And yeah, one of my colleagues is Marvin, sitting here. He's a security specialist in the team. But I work mainly with customers in the Benelux and the Nordics. I specialize in MSPs and MSSPs, so different companies that are managing Elasticsearch for their customers, and they also, of course, look into ways how to streamline this and make it more operational effective. So some of them use Elastic Cloud, but some others are using, for instance, Elastic Cloud on Kubernetes. Enough of me. I think quite a few. Let's move that one. Some of you actually jumped over the Kubernetes way to run serverless. I think you mentioned there, and so on. But quite a few companies are embarking on the journey to do containers, and with the containers also using Kubernetes to orchestrate their container workloads. And it comes with a lot of benefits, but there's also a lot of challenges in Kubernetes, especially if you use certain technologies like where you have like stateful sets and so on. It can be quite challenging. And with Kubernetes, we also have a lot of buzzwords. I think if you take a copy of this cloud native bingo, I think some might you may actually get to bingo, but I will try to avoid the buzzwords as such. But it's quite an interesting topic when you hear other presenting it, at least. And just to roll back, I think most of you might know Elastic and the stack itself already, but just to round it up for those who are watching the recording as well. So you might know Elasticsearch, which is kind of the core of the Elastic stack. This is where we store all the data. This is where we do this search and where we do the analysis of the data. And in order to interact with the data, we have a user interface called Kibana. This is where you explore the data, you can do visualizations of your data, and you basically engage with both the data, but also the rest of the platform through Kibana. And to get things into Elasticsearch, you have a few different options. And Neil presented, we have a few different clients in different languages, where you use the Python client, and also a handful of different clients you can use to interact, send data, and query Elasticsearch with. But for other use cases, like we have here on the screen, like observability and security and so on, we have something called Beats. It's basically a Go client that basically collects data and basically ships it to Elasticsearch. And Beats can be packaged and wrapped around something called Elastic Agent. And the agent you can also connect to Fleet to manage all these different agents or beats. So think of that you might are observing or providing endpoint security for thousands of servers. You want to have some way to manage all these different agents, and that you do through Fleet. I already mentioned that you have, of course, Elasticsearch and the Kibana stack, say the vanilla, the core functionality of it, but we have also done some of the out of the box, both integrations, but also say business solutions for, so you have like the enterprise search to basically collect all the data you have, for instance, in your workplace and make it searchable, or do like a search use case, like an e-commerce shop or something, where you can let your users to search through your catalog to find the next thing to buy. The other, say, use case is observability. This is where you collect things like logs from your applications and systems, or metrics from your infrastructure or application data, to just make sure that all the systems are healthy and everything is up and running. And that's basically observability. And the last, let's say, business solution is security. This is where you, all the way from, collect security events, maybe firewall events, or authentication events, etc. Or you actually want to go as far as to protect your servers and endpoints. So you have a security solution to do that, and to find incidents and so on that you might want to respond to and detect, of course. But this stack is deployable basically anywhere you want. So independent if you run it on bare metal servers, to VMs, to through containers, or Kubernetes that we will talk about today. You can run it in a public cloud or on your own machines on-prem, let's say, or also hybrid use cases where you have a cluster in the cloud, something on-prem, and you can do something that's called cross-cluster search. You can actually search these federated across, independent where they are deployed. And when it comes to the deployment options for the orchestration, or if we start with the self-managed stack, that basically means that you download and install, say, Elasticsearch on machine by machine, and you configure that through YAML and make them connect to each other into an Elasticsearch cluster and so on. And every time you want to update, you download the software, take out the node, upgrade it, and then connect it again to the rest of the cluster. And it can be, if you're running bigger clusters, this can be a quite heavy lift to manage. And the other options is to run it in our cloud SaaS service, where we run Elastic Cloud in the cloud providers where you like. It could be GCP, AWS, or Azure, and within all of those, in all the different regions. But for you that want to have a self-managed but still have help with orchestration of your clusters, you have basically two options. One is called Elastic Cloud Enterprise, which is like a platform tool that basically build your own private cloud. Or if you are into Kubernetes and run a lot of other applications, Elastic Cloud on Kubernetes is definitely an option for you, where Kubernetes is managing the orchestration of the nodes with you. I started in Elastic in 2017, and I remember the days still that we were, say, waiting who would win the container orchestration war. You had Swarm, you have Kubernetes, and a few others. So we were waiting there a bit, but I think in 2017, 2018, we saw that Kubernetes was kind of the winner in that Docker orchestration war. So that's where we went into the support for Kubernetes. But before that, in 2017, we extended these agents, these beats agents, so FileBit to collect logs and MetricBit to collect metrics, to run as like daemon sets in your Kubernetes cluster. And then in 2018, we released the Helm charts for Elasticsearch and Kibana to make it easier for you to deploy in Kibana as containers. We joined the CNCF, or Cloud Native Cloud Foundation. Yeah, exactly. I always mix that up. Thank you. And we also introduced in Kibana an infrastructure UI, because sometimes it can be a bit abstract what is running in my Kubernetes cluster, which pods have I running, on which Kubernetes node, and on the different pods, which containers are running and so on. So we made this visible through the infrastructure UI in Kibana. And then in 2019, we released something called an operator, first in alpha and then in beta. And that is basically a very easy way to extend the native Kubernetes functionality with a context on the application it's running. So basically, the operator lets Kubernetes know what Elasticsearch is, what Kibana is, and what are the dependencies between this. That you have dependencies between the Elasticsearch nodes, that you might have different Elasticsearch nodes, that you have things like masters, you might have data nodes, you might have hot data nodes or cold data nodes, and so on. So you're extending through the operator the native Kubernetes API with say Elasticsearch know-how in that sense. And in 2020, so 3 years ago, we released our first version of it, the 1.0, and currently we are on 2.7. And we basically have a new release every third month or once a quarter, you could say. And this is the Kubernetes. So it's actually brings a native Kubernetes experience to run your Elasticsearch and Kibana, and also some other functions like the APM server and so on this. And that do that through something called custom resource definitions. And these custom resource definitions are, let's say, these resources are like Elasticsearch node is a resource, and you through this define what for instance Elasticsearch is and what is required for that. And we support to run this operator in multiple. There are many different flavors of Kubernetes out there. So of course you have the vanilla flavor of Kubernetes, the open source. But then the public cloud provider has taken that into their own service offering. As for in Azure, you have something called Kubernetes Service, and you have the same flavors also from AWS and Google Cloud, of course. And then for you that are running this self-managed, you also have other options through, for instance, Red Hat OpenShift that you can run your own supported Kubernetes cluster or VMware Tanzu. I will pause there and actually start to show you a bit of a demo here, if that's interesting. See if this works. You see that here, and I will make sure, or I will do like this. I will see if I can zoom in. Clear there. Oh, it didn't. Is it big enough for you? You could read it at least. In Kubernetes, you have the kubectl command. That's nothing special, but basically you interact with what like you would do with any other Kubernetes clusters. You do this in a native, say, Kubernetes way. So I have now a 3-node Kubernetes cluster running in Google's Kubernetes engine. Small one, I think it's 8 GB nodes each, if I remember right. And this is totally empty, so it's totally, say, idle per se. And I have a cheat sheet here, and I will do like this as well. But the first thing you need to do, let's see if I can make it. We do like this. is to download this operator. So if I take just cube stuff, I will copy it here. So you basically download the operator from our website, and you can see that it starts to create this custom resource definition. So you have a custom resource definition for the Elastic agent, for the APM server, for beats, for the map server, for auto-scaling, for Elasticsearch itself, of course, enterprise search in Kibana. So there are a few different components that you say define in Kubernetes. So now my Kubernetes cluster know what Elasticsearch is, for instance, and what dependencies that are between them. And I will apply this operator as well. Let's see if I do the same thing there. So the next thing I want to do is, so now everything is ready, let's say, to start deploying your first Elasticsearch cluster. I'll just clear this to get the top. And I have, say, like a good TV chef, I have prepared some YAML files here, how I want my Elasticsearch cluster to look like. And you can see it's very easy. So you name your, so this is, I want to create something, I want to create Elasticsearch with a cluster with the name Quick Start in this example. I specify which version of Elasticsearch I want to have. And for instance, how many Elasticsearch nodes I want to have. So now I make the minimal, a 7.6 cluster standing off one node, let's say. So I will say apply this YAML file here. So kubectl lie f, oh, sorry, f is quick start 1. So now it should be start. It's created this cluster. So if I take kubectl get pods, you can see it started to, it created the first node here, and it's on the first step here. And I can actually do like this to see the updates. And this takes a few minutes, so I was thinking let's start this so we can wait for it to get them up and running, so you don't need to stare on this screen all the time. So we will get back to it and do a bit more as we go here. But running applications on Kubernetes also, as nice as it is with your orchestration and so on, it also comes with a lot of challenges in itself. All the resources are just generic, so it doesn't know anything without the operator about the dependencies that you have. You have a ton of different resources to manage. You have all the different pods, you have the nodes, you have services and so on, which is a lot of things to consider, not only to deploy, but also then to keep them upgraded and so on. And then when it comes to the storage, you have a lot of different storage classes, and this becomes even, I would say, even more challenging in that sense. In a stateful application like Elasticsearch, you don't want for sure not to lose any data. You want to be able to do upgrades and of course not lose any data. And with that comes things like high availability. You want to make sure that running, for instance, Elasticsearch, and you're running maybe mission critical for a power company or electrical company, you want to be able to do, for instance, you want to make sure that even if a Kubernetes node dies, you still want to have a fully functioning cluster. And you also want to be able to do maybe upgrades of Elasticsearch without any downtime and so on. So there's a lot of things that is a challenge in Kubernetes. And also, of course, if you deploy this and you maybe use this from a public cloud provider, you also want to make sure that the security is there so that you have, for instance, your applications using certifications to communicate with it, and you're using TLS for encryption and so on. And then on top of that, you might have 1 or 6,000 different namespaces and so on. So it's a lot of, say, complexity to manage in Kubernetes. And this is what this operator helps you. So it makes it really simple to make 1 or hundreds of clusters in Kubernetes. You just saw me spinning up one node right now. And it's very, very easy to do upgrades that I will show you later on. And it's super simple to scale. And as we do that, I can actually jump back to this one. So see where we are. You can see it's now up and running. And if I do, you can check kubectl get Elasticsearch. You will now see that we have one node of version 7.6 that has been up and running for a bit over 3 minutes, and it's green and healthy and so on. Let's now think that your data is growing. You're maybe running this as a proof of concept. It's time to maybe do maybe an upgrade. So to the latest 7 release as one example here. 7.79, we were at 7.6 right now. And maybe you also want to make it high available. So you want to have 3 nodes. So let's apply this this ES Quick Start 2 YAML. So we do a kubectl and change this to 2. You can see it's now configured, and you can see things happening here, that it starts to start the second Elasticsearch node called default-1. It's running that. And if we take a look at this one, it's still say not fully up and running there yet, so we can just wait for that one to become fully. We can do like this to get the updates. But I will move while that is doing its thing. Let us move back to the slides. And so, but it becomes very, very simple to do both upgrades like we did right now, and also, of course, to scale your deployment through Kubernetes. And this is just managing that for you. So instead of installing another VM with Elasticsearch and configure the YAML and so on, a lot of things is taken care for you. And what you can also do with the Kubernetes operator is to do, say, more advanced deployment. So what I did now with first 1 node and 3 nodes, then you can, of course, have a more advanced thing that you have hot, warm, cold, and frozen nodes to make it cheaper for time series use cases. And we also make sure that always that the cluster is have security enabled by default. So you will never say have an unsecure cluster. And we will also use the capabilities of Kubernetes to always make sure that you are using things like availability zones. So now when I have 3 nodes in the last example, when expanded, it makes sure that I have a node in region. Now I am in the Finland region of Google, but that I have one in every availability zones without me even having to specify that. Yeah, and I can run this both, say, in cloud and as well as on-prem versions. Let's go back to this one and see. We now have 2 nodes up and running, and you can see that it says 2 here, but it starts with 0. So it actually had the first one, all 3 up and running, but then first it expanded to 3 nodes, and now it starts to upgrade in them. So you can see that it's now going to 7.19 there in the background. So take us in steps for me, and it does that with say. The operator tells them in which order you can do certain things. So it doesn't take down all the nodes at once. It always makes sure that you have a fully function cluster while you're doing applying these changes that you have, say, specified. But while it's doing that, it's still functioning. So let me also deploy a Kibana node. So because now we have only done the Elasticsearch part. So I also have a YAML file for Kibana telling me that you should connect to the Elasticsearch cluster called Quick Start. You should have this version 7.17.9 and one Kibana node. Yeah, oh, sorry, here's the Quick Start Elasticsearch reference, so it should connect to that cluster. So if I do the same now, apply Kibana, it creates Kibana, and you can see it start up a Kibana node directly here, and this also takes a few minutes until it's up and running. But you can now see that my Elasticsearch cluster is up and running. It's green, it has 3 nodes, and the version is 7.17.9. And while I'm doing that, I should also take a chance. Remember that I was all so that you always have security on. So it creates an, of course, the default user, the Elasticsearch user by default. But I just need to get the password out. So we get that one. So basically getting the first time password. So I will save that. Take it here so I can connect it later on. So let's go back to the presentation. So, and this is just basically a bit of summary what we just mentioned, but it's a really nice way. You have this in the free version of Elastic, so it's free to use, but there's also a paid version that gives you paid features like machine learning and so on top of the Elasticsearch. And we support all the different types of many of the Kubernetes distributions that is out there. And it extends the Kubernetes experience with a native experience using the Kubernetes API. So you use kubectl to operate and control your Elasticsearch cluster and components. And this is also a bit of what we have just talked about, most of the things, that everything very easy to configure. You can also, of course, enable something called snapshot, basically like an incremental backup to make sure that you have a backup of your data all the time. We talked about that you can have more advanced topologies with hot, warm, cold, or frozen deployments. You can also do this cross-cluster search. So you might have maybe an Elasticsearch cluster in K8s or in Azure's Kubernetes service. You might have on OpenShift on-prem, for instance, but maybe you want to search across these at the same time. You can do that through cross-cluster search. You just connect those two clusters. And last but not least, you can also enable something like auto scaling, so you don't need to go in and say that I want to expand it to 3 nodes and so on. So you can have this automatically for you. That you can assign a certain budget how much the clusters and machine learning nodes are allowed to scale up to. So it's can be done automatically for you. Here was the demo, but I was thinking to run it here in between. So let's see where we are. We are with Kibana. So green. So we have a Kibana up and running. And as this is in cloud, I will need to port forward this to. So that's another a step before that, just to show you that Kubernetes automatically creates services for you. So if you can see it, that we have also like a load balancer for you, so you can interact with the Elasticsearch to expose the 9200 port for you. But if you want to access that from this outside of Google Cloud, we need to do port forwarding. So I would port forward the Kubernetes cluster like this. So, and if I get this right, so if I just do like this, it's local host 601. It says it's not private because I don't have like a signed certificate. But now I'm connecting, I have the user, and I want to remember the password. Log in, and voila, we have the 7.17.9 cluster here. So this was a very quick demo to show how, I would say, easy it is to run Elasticsearch in Kubernetes. And if you haven't tried it, try it. It's quite fun, and you will learn a bit of Kubernetes as well on the way.